Hi and welcome. In this video, we're going to introduce the concept of polynomial functions. So in general, we say that a polynomial function can be written in standard form as the following. So we would write f of x equals a times x to the n power plus b times x to the n minus 1 power plus c times x to the n minus 2 power, etc., decreasing the powers until we get to our d times x term, and then plus e, a constant at the end. So this looks really general, but the idea here is that we just have a number times a variable to a power. So a times x to some power, and then that gets added to other terms that are the same type. N is then our largest power, and then we just have all of the powers below that. So we say that the degree of the polynomial is that largest power n. So if we look at that exponent, the number that is the largest of all of the exponents, that's our degree for the polynomial. We typically write it as the first term. Someone might hide that somewhere else in the formula. Convention is to typically write it as the first term. So a times x to the n, that n is the degree of the polynomial. Then, similar to in the other functions we've learned, a is the leading coefficient. So that's the value that gets multiplied by whatever term has the largest power. So this is our polynomial function, but before we get to the examples, let's quickly talk about domain and range. The domain here is going to be all real numbers, so negative infinity to positive infinity. That's because any input is valid into this function. We can give the function any input x and it will work just fine. And then the range is going to depend on the polynomial. So we'll see some examples, but depending on the shape of the graph and how the polynomial behaves, that's going to affect the range. But the domain is always all real numbers. So let's start with an example we're familiar with. We've learned quadratic functions previously in this sequence of videos, and so a quadratic function is actually a type of polynomial. So let's start by looking at a quadratic function. Let's suppose we have f of x is equal to x squared plus 3x minus 4. So this has our form of a polynomial. It's something times x to a power plus something times x plus our constant. So here we would say the degree of the polynomial is that largest power, so that's our 2. So the degree is 2 here. And then the leading coefficient is the number multiplied by that term, so here it's 1. So even though we don't write the 1, 1 is the leading coefficient. So we might say this is a degree 2 polynomial with 1 as the leading coefficient. So let's look at the graph. We should be familiar with this one. As x squared plus 3x minus 4, this is a quadratic, which is a type of polynomial. It has a domain of all real numbers, and here we're seeing the range is everything from about negative 6.25 up to infinity. So as we look at other examples, you'll notice that they look different from this shape, but this is just one of our possibilities for a polynomial function. Okay, let's look at another example. Let's suppose we have g of x equals x cubed. So this is a very basic polynomial function. It just has this one term, x to the third power. If it's confusing and you want to see why it's actually a polynomial, you can think about writing it as 1x cubed plus 0x squared plus 0x plus 0. So in this way it follows the pattern where we have the term with the largest power and then we cascade down. Basically we get one less on the exponents each time. So we have an x squared, then an x, and then a constant. But we typically don't write those 0 terms, we just write this as x cubed. So here we'd say the degree is that largest power, which is 3. So this is a degree 3 polynomial, and it has a leading coefficient of 1. Again, there's a 1 in the front, even though we don't typically write it there. So this graph is going to look a little different from other things we've seen. So if we have x cubed, this is a polynomial, and to look at the graph, let's think about plotting some points. So we'd have an input x value and then an output x cubed. So if we had 0, the output would be 0 cubed, which is just 0. 1 has an output of 1 cubed, which is 1. Negative 1 has the output negative 1 cubed, when we do a number times itself 3 times, if it's negative, it will still be negative. So this is still -1. And then if we have -2, that's -2 cubed. That's going to be -8. So -2 times -2 times -2, we do that 3 times, and that gets us -8. So I choose these points because they fit on my graph here, and we can see we're getting this S shape that goes through the origin. Sometimes I think this even looks like it might be a parabola, except that left-hand side just got sort of turned downward. So this is our degree 3 polynomial, our most basic one, x cubed. And here you can see the domain and the range are both all real numbers. So the domain is -infinity to +infinity, and then the range is also all real numbers, -infinity to +infinity. So this is where the range is going to vary depending on the polynomial. Okay, let's look at one more example. So here, let's suppose we have h of x equals -1/5 x to the 4th minus 7/5 x cubed plus x squared plus 15x. So this is a polynomial. It has our pattern of a number multiplied by a variable to a power. We don't have a constant at the very end. We end with 15x, but that's okay. This is still a polynomial. When we go to look at the degree is that highest power. So here that's 4. So that biggest exponent is 4, and we would say this is a degree of 4 polynomial. And the leading coefficient is the number that is multiplied by the variable, so that's -1/5. Now this graph is going to look very different from what we've seen so far. So let me put it here. This is a polynomial. It has lots of twists and turns. The domain is still all real numbers, but you can see the range basically is everything from -infinity up to 20. It's not really 20, it just looks like it on this graph. It's actually something like 19.978. But the idea here is that our polynomials can have lots of varying shapes. When we start putting more x's on it in this way, like different x terms, we start to see these turns of the graph and multiple horizontal intercepts, that sort of thing. So we'll get more into the details in future videos, but that's just a little introduction into what polynomials might look like and how to identify the degree and leading coefficient. That's it for this one. Thanks so much for watching, and I will talk to you in the next one.